need to record this. Okay. Let me just show you on that spreadsheet that I had you open up there. So right at the top of that spreadsheet, it says, it has a section called simple versus compound interest. And so you can think about these as like a savings account. No savings account today is going to pay you 8% on your deposits. They'll probably pay you 0.5% or something like that. But for this example, we'll just say 8% is what the bank tells you you'll earn if you deposit money with them. So in this top, on rows 3 and 4, this top section, this is an example of simple interest. And basically what happens with simple interest, and I'll start, I guess I should start out with telling you what PB is. PB means present value. You can look over here on the left-hand side and you can see it's just an abbreviation that we're going to use for present value. What that means is what something is worth right now today. So present value of your deposit at this bank would be, if you took $1,000 and deposited in the bank today, that's the present value of that. So that's what you start with essentially. And then what happens is that every year you leave it in there, you earn 8% on this total, 1,000. So after year 1, this is what 1, 2, 3, 4, and 5 represent here, a number of years or time periods. You would earn $80. That's 8% of $1,000. You'd earn $80 on that if you kept it in there for a year. So at the end of a year, you'd have $1,080 in there. If it's simple interest and you just left it in there, then year 2 you'd earn $80. Year 3 you'd earn $80, and any number of years that you left it in there, you'd essentially be earning $80 per year. Simple interest basically means that you're going to be earning interest on whatever you put in there at the beginning, not what adds up and grows as you earn interest throughout the years, but just this initial amount, this present value amount. That's simple interest. Compounded interest or compound interest is when you take that same $1,000 initial investment, earns the same 8%. At the end of the first year, you have the same amount, $1,080, you've earned $80. But the second year, instead of earning $80 in interest, you earn $86.40. Anybody know why that is?
Are you paying 8% of the $1,080?
Yes, exactly. You are earning 8% on $1,080 in this for the second year that you keep it in there. So that's what compounding means. It means you earn interest, which then goes back into this principal value, and then it calculates interest on this new value during that year. And so if you leave this money in there every year and it keeps earning 8%, every year you earn slightly more in interest because your value is increasing slightly throughout periods of time. So to compare simple interest to compound interest for this example, you can see that by year 5 you're earning $108.84, and in year 5 of simple interest, you're still only earning $80. So the difference in interest over a 5-year period, just between a simple interest account and a compound interest, is basically you're earning $69.33 more in interest if you had compound interest versus simple interest.
So simple interest, that can you just set that up by putting in your savings account and you could eventually draw from it, right? Is compound interest, you can't draw from it, right? Is usually agreement with the bank or?
No, it's most bank accounts actually. Simple interest you don't really see that much at all. Right. So even your savings account will say it will compound maybe once every, some compound daily, not very regularly, but some will compound your amount daily. Some will compound it monthly, quarterly, or yearly. And so, but that doesn't mean you can't take money out. That just means when you take money out, you're going to be earning interest on that little bit less, okay, of the money that you took out.
And is there a special like compounding? Can you just get an account for compound interest? Like, is it like money management? Can I put like $20,000 in this compound interest so I can make money 20 years, or like for retirement maybe? Or
Well, I mean, any savings account or CD will have some form of compound interest to it. If they don't, then the bank's really making good money off it because they're not paying as much interest back to you.
The rates vary too, probably on the banks and stuff like that too, right?
Yeah, the rate certainly between different banks, you'll see different rates for CDs and savings accounts, and some checking accounts will pay interest.
so the interest rate varies from each bank.
Yeah.
So is 8% the highest you've seen?
Oh, 8% doesn't even happen right now. Yeah, no. Right now, most savings accounts are like 0.5% or less, so 0.5%. If you put $100, if you put $1,000 in there and left it in there for a year, you'd earn $5. So there's not much incentive right now for people to save money, at least in banks, because the interest rates are so low. When inflation was really high in the early 80s, when the inflation rate was like 14-15%. Right now it's about between 1 and 2%. Right. In the early 80s, it was literally 14 or 15%. At that point in time, you could probably get a savings account that would pay you maybe 8%, maybe even 10%.
That's not locked in, right?
No, the savings account will just change. A certificate of deposit will lock you in for a certain term at a certain rate. So like a 1-year CD, certificate of deposit, will pay you whatever. It's probably going to pay you a little more than 0.5% maybe for a year, and it's locked in.
And the longer you have a CD, the more you probably
Yeah, the longer you have a CD, the incrementally more interest they'll pay you because you're locking your money up for a longer term, basically. So this is the difference between compound interest and simple interest, and why almost everybody, all financial institutions certainly, calculate things based on compound interest. And this happens the opposite way for loans. So if you have a loan with a bank, they will compound the interest on that loan too, right? So they are charging you more interest on your loan because they're compounding it a certain number of times during the year, as opposed to just calculating simple interest for you. So, yeah. But everything we're going to be doing in here essentially is deals with compound interest. Nothing, I can't think of any examples in which we're going to be calculating simple interest. It all revolves around compound interest and compounding. All right, so any other questions about compound interest and simple interest? It's just sort of an initial introduction to these concepts. Okay. So a follow-up question to this: why is $1 today typically worth more than $1 a year from now, as far as your ability to buy things with $1 or $10 or 20 or whatever? Why is it worth more today than it would be a year or 2 years or 5 years from now?
Is it mostly because the prices of things go up, maybe?
Exactly, yes. And that's called inflation. So as prices on goods, whether it be TVs or food or insurance, go up every year, which they tend to do, although right now we're sort of in a time where there's actually worry that prices are going to start falling a little bit because the economy is sort of in a tenuous place right now. But anyways, for most part, you will have some gradual inflation where, like right now, inflation, let's say, is 2% in the United States. That means every year your dollar will lose 2% of its purchasing power. So what you could buy for $1 today would take you $1.02 a year from now to buy the same thing. So an apple that would cost you $1 today, assuming inflation was equal, which it's not, it varies between different products. Obviously, gas hasn't inflated this year, it's deflated, it's gone down in price. But if we just want to apply that concept and say 2% inflation occurs, then that same apple that costs you $1 today will cost you $1.02 next year. So basically, you're gradually losing purchasing power as time goes on when there's inflation. And so that's one of the reasons why the calculations that we're going to be doing here, we're often going to be looking at calculating present value, which is what something would cost today. But sometimes we'll be calculating the future value, what something will be worth in the future. But you always got to keep in mind that for the most part, what a dollar is worth in the future is going to be worth, it's going to be worth less than it is today. And that's just called inflation. Things gradually go up in price. Cars, food, services, anything you can buy typically goes up in price. And so that relates back to compounding, just like everything else. You could compound inflation every year. If inflation is going up 2%, then you're not losing 2% year one and 2% year two and 2% year three. You're losing 2% and then 2% plus some amount in year two, and then 2% plus some amount in year three, because inflation compounds just like interest compounds. So you can lose money in a compounded fashion just as much as you can gain money in a compounded fashion. So something to keep in mind. All right, so all of that is my way of prefacing what we're about to do with 6 functions in Excel. And they're called time value money functions because what we're going to be doing is calculating the value of investments or loans or things at different periods of time. So sometimes we'll be calculating in future value, which is FV. Sometimes we'll be calculating for present value, PV. Sometimes we'll be calculating what the interest rate would be on a particular investment or loan, and that's just called interest rate, excuse me. Sometimes we'll be calculating, say, the number of years that it would take to pay off a loan, and that's called number of time periods, or NPER. These are the FV, PV, rate, NPER. These are all the functions in Excel that we're going to be using. I'll show you how to use them in a second. We're also going to be calculating payment amount. So if we have a loan for a car and we know how much it costs and we know how much interest they're going to charge us, then we can calculate what the payment's going to be every month, and that's called PMT. And so we're going to go through some examples here. And so I'm first going to show you how to use these functions with some example exercises, essentially. And then hopefully we're going to have time where you get to practice a little bit of this, because then you're going to get to do it as an assignment for next week. This last, and I didn't mention this last function down here, IRR, stands for, I guess I should write that in there, internal rate of return. And that means that sometimes an investment won't have like an even return. So you won't always get, say, 5% every year for the next 5 years. If you're investing in, let's say, upgrading a restaurant, if you're putting in new finish in a restaurant, hoping to attract more customers, you're probably not going to gather. You may gather a lot in year one, and maybe a little bit less so in year two, but every year you're going to be sort of gaining more and more as those accommodations, those finish, become worn and are not as exciting to people who want to come to your restaurant. And so in that case, we have to try to figure out an average return based on different compounded rates every year. And so that's when we use this function called IRR, or internal rate of return. I'll save that to the last because that's sort of the most, of these functions, that's the most complicated. So in week 5, there should be, you don't need to open this up if you don't want to, but there are a couple in-class links here. And the one I'm going to click on is in-class time value of money examples. And so these are just 4 or 5 different examples of the types of questions that you could be asked on your test next week and use to calculate, use these functions to calculate. So I'm just going to open it up big here. See if I can move people around. Move it over there. Anyways. Okay. So there are 5 different questions here. And so I'm just going to go through the process of showing you how these functions work. You can play around with them in Excel as I do too, if you want to see how they work. But this is what I'm going to use as a basis for showing these functions, these problems. So this first, actually, before I get into these exercises, let me just give you a brief background of how these work. So if you see in each of these, for each of these functions, I have to the right something that says equal something, equal FV and then parentheses, or equal PV and then parentheses. So this is how you start, this is what you type into a cell to start one of these functions. It won't work directly, you can't type directly into these cells that already have the equal in there because I made these text boxes. So when you make a cell a text box, that means Excel's not going to try to calculate anything. It was the only way I could show how to initially type these functions in here. So these are called functions. You can look up all sorts of functions here under FX. But I'm going to start over here, and I'm just going to show you a brief example, and I'll sort of tell this verbally here. But all you do is start out by typing equal FV, whoops, and then your left bracket. And then if you look without typing anything else below there, now all of a sudden you have these, it's basically their prompts. And this is sort of instructing you how to enter a function, and it tells you what to put and when. So the first thing we'll need to put in a future value function is the rate, which is the interest rate. So let's imagine that we're calculating, we want to retire in 30 years. And we're going to invest something today, and it's going to earn the same interest rate for the whole 30 years. And we want to see how much it will be at the end of 30 years. So let's imagine that one of our relatives died and they left us 10 grand, okay? And we found a bank that, for whatever reason, can get us 2.5% for 30 years. So our rate, the first thing, is going to be in bold. Whatever it's prompting you to input here is going to be in bold down below here. So the first thing is rate. So we want to put in an interest rate of 2.5%. In decimal form, what is 2.5%? How would I write that in here? Got to move the decimal points to the left, right? If you're taking it from percent back to decimal, you move it to the left. So instead of 2.5, it's going to be 0.025. That's the same as 2.5%, 0.025. So I type this in. This is my interest rate. I hit comma. That's how we separate these things. And then it bolds up this next thing, which is N per. N per is the number of time periods. So how many years did I say I was going to invest this for? 30 years. So I'm going to put 30 in here. Number of years, 30. This also assumes that we're compounding this amount once a year. That's what time periods. If we were compounding it once a month, and we'll do this for home loans, then instead of 30, if it was 30 years long, we would do it in months. So instead of 30, it would be 360. Yeah, 360 for 360 months.
Oh, gotcha.
Yeah, but we're just going to do years for this example. So we got our 30 in there. We put another comma there, and then bolds up PMT, which is payment. Payment would be, we're not going to use it for this example, but it would be like if instead of just investing money today and leaving it there the whole time, maybe you invested a certain amount every year for 30 years. So if you put in an extra $1,000 every year, that's where your payment would go in. But we're not going to do that here. So if we're not going to use it, you just put 0 in there. Okay. And then the last thing, and Okay, so for each of these functions, the last thing is going to be type. Don't worry about putting type in there. It's optional, and we're not going to use that function. So just worry about the first 4 variables. So the last thing is this PV. And PV means what is the present value. So because we're investing this is how you have to think about positive and negative numbers in these functions. If you are giving something, or if you're investing something and putting money somewhere else and it's going away from you, that's a negative cash flow, right? Even though it's still yours, it's no longer in your possession. It's somewhere else. It's in a bank. So in this case, because we're investing $10,000, we're going to put this in as a negative $10,000. And I'll show you why in just a second. Okay, so I've entered all 4 of those things here. Don't have to enter type. Don't have to put a comma after this. You can, in fact, just hit enter right now. You don't have to put that last bracket in, and it will calculate for you. So this number that it calculated right here, 2,000 or 20,000. By the way, can people out there in Zoom land, can you see these numbers all right? Or shall I make them bigger? Because I can make them bigger.
I have a hard time seeing them, but it might be just my eyesight.
Okay, no, that's fine. I'll make them bigger.
Mhm.
Okay.
What data is it pulling from? Where did they get that 20,000?
This is the function. That's what it just did. We're saying find me the future value based on these 4 variables.
Oh,
Ba-
the number of internal estimate.
No. It's based off of what we just put in the brackets there.
Okay.
0.025 is the interest rate, 30 years, no payments, and an initial $10,000 investment.
Oh, okay. It comes up.
Yeah.
This is your example, right, for that?
Yeah. So this is just an example of how you can use this function. So that's one way to use the function, but the reason I've set this table up like this is because the other way you can do it is, I think it's much easier, and we can get you the same result. So I'm going to just delete this here. So remember, $20,975. We're going to use the same example, but I'm going to put them in different cells here. So the rate is going to be 0.025, and since this is in percentage already, it puts it into percent. So 2.5%. N per is 30. I'm going to put it there. Future value, we don't know. That's what we're calculating. Present value is the negative 10,000. Payment is 0. And so one of the things you can do here is just go into this cell, for instance, and you can hit equal FV, because we're trying to find out the future value again. And then it's prompting you here for the rate. Instead of typing in the rate, you can just click on the cell that the rate is already in. So you can click on that. Okay. And C12 just refers to C, column C, row 12 here. Hit comma. Now it's prompting us for N per. I can just click on that. Comma, payment. Click on that cell. Comma, PV. Oh, this is going to be hard because it's right next to... Here, let me not do that in that cell right there. Let me do that over here. This will make it a little easier, I think. Whoops. Because I was having trouble clicking on that cell just because of where it's at. So rate, comma, N per, comma, payment. And all I'm doing is clicking on these cells after I hit comma. Present value, click. So now it has all these cells in here as opposed to the numbers I manually typed in. But if I hit enter, it should come up with the same number. If it doesn't, I'm going to be very disappointed. Okay, good. So it did. So this is probably the way I would recommend that you do it, just because it makes it a lot easier for you to see what you've entered. But the other thing it makes that's really cool about this is you can do some hypothesis testing. You can say, okay, you know what? I just found out that this investment, I just found out about an investment that would pay me 3.5%. So instead of 2.5%, I want to calculate this for 3.5%. So then all I have to do is change this one cell, 0.035, hit enter, and then this recalculates it based on that. So then you can change any of these variables in here, and it will recalculate it automatically without you having to go in here and change a number. You can just change a number in here. If you wanted to do it for 40 years, you just put 40 in there. It's going to recalculate it based on that. So I highly encourage you, as opposed to entering these things manually, to enter them in cells like this. That's sort of why I set this up this way. And then you can change all of these variables and it will change the calculation automatically. For a numbers guy, it's sort of a cool thing. It's a geeky thing, but I like it. Okay, so that's just an example of how you enter a function, and that was the future value function. We have 6 different functions we're going to be using here. That was the first one. Any questions about that, about any of that, any of those entries or the concept or anything else that I've been talking about? No? All right. So let's let's take a 10-minute break so you can all sort of let your brains relax and get your body moving a little bit. And then we'll come back and we'll run through the rest of these functions. And then hopefully there will be time for you to do some practice ones in class. So let's take 10. According to my clock at 6:03, we'll start up again at 6:13.
What's 25 or what do we put the percentage? Is it 2.5%? What is that? And 2.5 is.
So you'd move the decimal point 2 to the left.
Okay.
Yeah, so it'd be 0.025. And if you're converting from decimal to percent, it's moving it to the right.
Yeah, that function's awesome. All you have to do, because I got the rate wrong, and all I had to do is fix the rate and then match the number.
Mm-hmm. Yeah. Yeah. I like these functions. They're pretty cool.
Man, that's crazy, man. So back in the day, before all this, somebody had to go on a chalkboard, huh?
Well, yeah, there's before Excel. So if we were doing this, I don't know. I mean, they still calculate some of this by hand in some math classes, but there's actual formula that you can go in. It's like, you can look it up on Wikipedia, but you got to do some exponents and things. I did it way back in the day, but I can't remember what it is now. But yeah, where you would put the same information into a formula and then crank it out in your calculator. You can still do it, but yeah, now we have these functions and it just makes things so much easier.
Was the probability of human error more back in those days?
Well, yeah, I mean, you were doing all those calculations yourself, and there were some things that you were putting to the power of the number of time periods was like the exponent. So you had to calculate something and then put that to the exponent of that. And yeah, so it was really easy to make mistakes. This is
and was this an acceptable tool like overnight, or did it take like 10 years before accountants were able to trust it? Or?
I think I don't know when Excel started building in these particular functions into Excel. I know that when I was in grad school in 2003, that we were still using financial calculators. That doesn't mean that these functions weren't necessarily in Excel at that point, but it was still pretty common back then to use financial calculators to do these time value money calculations. It could have just been that the people teaching us weren't familiar enough with Excel to know about these functions. But yeah, it
took a little while for this to become the norm.
Yeah, I think so. I mean, yeah, I think.
Well, if you think about it, if an accountant is using every day to do it by hand, it takes him a certain amount of hours, and then he can do this all in like 20 minutes. He's probably like, I have like so many hours free now. But, wow.
I saw those old big books like that were they were like the spreadsheet and this, and they had like those massive pages too.
Yeah.
Wow, man.
Yeah, I'm glad I wasn't doing accounting 20 years ago. It would have been rough.
That's what I heard. One of the big benefits of this was if they were doing like an annual report or something, and somebody noticed a big glitch, like instead of spending days or whatever to try and get those, you could do like you just did and go change a cell, and it'll save you like how many hours.
Yeah. Going back and finding errors, I think, is a lot easier with this.
Mortgages, 4% interest. So, and then what's 4% interest? How do you like it?
Interest.
Mm, 20 years.
Lena, it looks like we have a new student there.
I didn't get it.
All right, so let's get started. Restarted. So I'm going to go through these examples here. So you won't just have to listen to me explain what the example is. You can actually see it as long as I can read it. Wish this thing would go up. There we go. Okay. So this first example is you invest $3,600 per year in your IRA for retirement, individual retirement account. If you do this for 20 years and your IRA averages 4% interest, how much money will you have when you retire? So this is, what are you trying to figure out here? Something in the present or something in the future? Future. So this is one of the things you have to do when you do these exercises, determine which function you need to use based on what they're asking you. And so in this case, you're going to be using the FV function, future value. So you invest $3,600 per year. So this is not like the one we just did, because this is something you're going to be doing every year for the next 20 years. So if we go back here, we're going to just change this up. I'm going to leave my FV formula right there, and I'm just going to go in and change. I'm actually going to delete all those. I'm going to enter these again. And it keeps these cell locations, so you can delete them all and then re-enter them, and it will recalculate it based on that. So we set an interest rate of 4%, so I'm going to put 0.04. Number of time periods was 20 years, 20. Future value, we do not know. That's what we're trying to figure out. And by the way, so in all of these functions up here, these 5 functions, you're going to need to give the function 4 of the 5 variables, and it will figure out the 5th one. So when we do present value, you're going to be giving them everything, rate, N per FV, and PMT, and then it will figure out present value for you. So just conceptually, that's what we're doing here. Present value of this. What do you think the present value of this particular one is? 0, exactly, because we just said that, or the exercise said that it was just contributing, the person was contributing $3,600 a year. So we're going to put 0 there, present value, nothing. PMT, so this is where you put an amount if you are doing something over and over and over again. And in this case, we're doing this for 20 years. We're putting $3,600 into this account that's earning 4%. Again, because you are putting it in and the money is going away from you, this is a negative thing. So it's going to be negative $3,600. I hit enter, and hopefully this will calculate right over here. Let's see though. Boom. Yep, it did. So if you invest $3,600 a year for 20 years and it earns an average of 4%, then in 20 years you'll have $107,201.08. So that's the answer to the first part of this question. And the second part, oh, and so this is the other thing. Be careful on these exercises, because a lot of times I'll include 2 questions for one. I'll say, okay, so the first part of this question asks, what if you do this for 20 years? But then I say, oh, but what if you started earlier in your career? I'm sort of encouraging you to start earlier in your career to save for retirement, because compounding takes a big effect. So the more time that you allow your investment to compound, the easier it is for you to earn more money. So my second part of this question is, what if you started earlier and invested for 30 years instead of 20 years before you retired? So all I have to do is go back in here, change my N per from 20 to 30, And yes, exactly. You add 10 years and you virtually almost double your retirement amount in your IRA at the end. So it goes up to $201,905. All right, so that's a future value type question. Any questions about that? Either of those two? Oh, and so the other thing you could do, you can be really crafty if you want to. You can say, okay, this is what I'm going to do every year. But you know what? I actually started out with this money that my aunt gave me. I'm going to start out with 10,000. So you can actually put in not 100, 10. You can put in 10,000 in the PV, present value category, and hit enter. And it's going to show you again what's going to happen. So this says that you invest $10,000 initially, and then every year after that you put an extra $3,600 in for 30 years at 4%. This is what you'll have at the end, $234,000. Okay, it's a nice number. All right, so that's FV, future value. I think the second one here, hopefully. So the second one is so here's the question. You have found a wonderful home and are interested in buying it for $250,000. If the bank is willing to give you a 30-year loan at 4% interest, what would your monthly payment be? What would be your monthly payment? So which of these 5 functions do you think we're going to be using to find that answer?
Payment function?
Payment, exactly. We're looking for a payment, okay? So let's go back to this. $250,000, 30 years at 4%. This is, but we're looking to find a monthly payment. So keep that in mind with this one. When you do these functions, you're going to have to decide whether you're doing something in years or in months. Typically, those are going to be the 2 time periods. And so I'll show you in this case, we want to find out what our payment's going to be every month, right? So I sometimes have problems with this, so we'll see how this works out. So for this one, again, actually what I'm going to do here, this is another cool function. So I'm going to copy this function that I put up here, and I'm going to put it down right here. Paste. Okay, it says 0 right now. What it will do, it will, when you copy a function, it will then say, it doesn't go to the same cells, it goes to the relatively the same cells. So because the function was here and it was pulling from everything to the right, when I copy it down here, the function is here and it will pull everything from the right. But I do need to change this function from FV to NPER so that it calculates the right thing. Okay. So let's see how this works out here. Actually, I'm not going to do it that way. We're going to put the rates in first and then we'll do it. So the interest rate is 4%, right? But we want to figure this out on a monthly basis, not a yearly basis. So what we have to do with the interest rate is we have to figure out what the interest rate is every month. That's pretty basic though, really. All you have to do is, I'm going to put equal 0.04, which is 4%, right? Divided by 12. That's what the interest rate every month would be. And so I put that in there. I don't even think I needed to put brackets on it. Let's just see. Whoops. Oh, I guess I did need to put brackets on it. So it comes out to 0.3%. If I added a few decimal places, it would be 0.333 to ever. But so this is the monthly interest rate, 0.33%. Every month be 0.33. We said it was a 30-year mortgage, but if we're doing this in months, then what are the time periods there? How many?
36. 39 months and it's a 3 year.
It's a 30-year.
Oh, 30.
Yeah. 360 months.
Okay.
360 months are in 30 years. So that's going to be our time period. All right, so let's see. This is the part that I always not always, but sometimes they get mixed up. The amount of the house is $250,000. I'm going to try it this way. Negative $250,000 in present value, because that's what the house is valued at right now. That's what it would cost me if I was going to buy it with cash, $250,000. The future value of the loan will be zero, right? In 30 years, if we made our payments every year for 30 years, the balance of the loan would be zero. So zero. So this is actually, these values are the value of the loan, not the value of the house itself. So let's go back here, and I'm going to do equal N per bracket rate, comma, payment. Wait. We're trying to find payment, not rate. Sorry. Let me do this one more time. PMT. We're going to do PMT here. Sorry about that. So we do rate, comma, N per, comma, PV, comma, FV. So I got my 4 cells in here. I should just be able to enter here. Yay, I did it right this time. So your payment, your principal and interest payment on a loan for a $250,000 loan, this is assuming you put no money down, at 4%, every month you would pay $1,193.54. That'd be your, if anyone owns a home, you also know that you then also, well, in most cases, you pay property taxes and home insurance on top of that, so that increases that amount some. But so that is payment. That's the amount. Actually, I'm going to move that down here so that's right next to payment. Any questions about that payment function? This is calculating how much you would pay based on this information. So the second part of this question is, what if the interest rate were, it shouldn't be were only, it should be were 6%. So instead of 4%, it's going to 6%. So again, just like this equation up here, I can change these variables. And instead of 0.04 divided by 12, I can say 0.06 divided by 12, which gives me a monthly interest rate of 0.5% and a monthly payment. My payment goes up to $14.98 So it increases quite substantially if your interest rate goes from 4% to 6%. Which, if anyone is considering buying a house, now is a pretty good time if you can get a loan to get a loan, because rates are super low. They might stay that way for a while, but you never know. They're literally historic lows. They have never been this low before. So you can get a loan. If you have good credit, you can get a loan on a home for a 30-year fixed rate loan for about 3.5% probably right now. And when I bought my first house in 1996, man, I feel old when I say that. I think I was paying 6.5 or something like that. So interest rates are pretty low right now.
Can you highlight your rate real quick? I want to see if the formula, I think if they're right next to it, 50% for 0.50%.
Oh.
That let's put in equals 0.4 divided by 12, and it gave me 0.03%.
Right.
And then when I did the whole function thing, we're doing the paint that. You do in per or? I
accidentally did N per at the start, and I should have done
okay.
payment. Yeah. So that was my fault. PMT, right? Yeah. All right.
Is there a way that you could figure those out, like, for the loan mortgage? If you would you just take that off PV?
You are really cutting out on me, Melissa. I can barely hear you. Yeah, I can't hear you at all right now, actually.
Okay.
A little better. Can you type me your question? I don't know if I'm going to be able to hear you. All right. Anybody have any questions about that? Yeah, Melissa, if you chat me or send me a chat with that question, I can try to respond. No questions from anyone else? All right, moving on. So number 3 here is, as you near retirement age, annuities begin to look like an attractive investment. Let me see here.
So in annuity, you just give them a large amount of money and they just give you money off that. Is that what annuity is?
Yeah, let me talk about that in just a second. Melissa, I'll answer that question right now. That's a good question. So Melissa asked, is there any way we can figure this out if there is a down payment? And yes, you can. And the easiest way to do it is, let's say it was this $250,000 house and you were going to put $50,000 down. So instead of being a present value of negative 250, it would just be negative 250 and take off 50,000. So it would go down to basically be your loan amount, whatever your loan amount was. So it'd go from 250 to 200, and then you hit enter, and it reduces it down over here. So that's how you would do it. You would just subtract off the down payment from whatever your loan amount was here in the first place. So, sound good? Okay. All right. So back to the example here. Number 3, so an annuity. An annuity, Luke was asking, an annuity is basically an investment where you give a company, an investment company, a chunk of change right now. Like, let's say you give, you want to retire in 2 years, let's say, and you want to guarantee yourself a certain amount that's coming in every month for your retirement because you're on fixed income. And so what you can do is, instead of keeping money in an account that's earning interest over a period of time, an annuity is like, you give them a large amount of money at the beginning, and then they calculate out a return, and they pay you out every month for a certain period of time, the same amount. So, so if you wanted to have, for instance, so here, let's just do this one. I think it's easier for you to see than me explain it. So this person is interested in annuity. One company offers an annuity that pays $1,500 a month for 25 years. So this is the return that this person would get from making this investment, is that they would get, this company would pay them $1,500 a month for 25 years. So for retirees, having that income, fixed income for a period of time is pretty attractive, as opposed to having your money in the stock market, where the stock market could go down and then you can lose a bunch, and you don't want to be there when you're retired. So $1,500 a month for 25 years, they charge $175,000 for this annuity. That means that you give them $175,000 today, and in exchange for that, they will pay you $1,500 a month for 25 years.
So so their benefit, the reason why they do this is because they get to have that money for their capital to do whatever, right?
Yeah, so from the company's point of view, the way that they're hoping to make money is they're hoping to take your $175,000 and make more money than it takes them to pay you this amount over 25 years.
Cool.
Yeah, that's their game. So the question is, what is the average rate of return on this investment? So this is about interest rate, or rate here. And so let's see, we're trying to figure out rate, so we need to enter all these other things. So the number of time periods is going to be the 20. Actually, it's not going to be, let's see here. This is per month for 25 years. So again, we have to do this by month. So 25 years in months, 25 times 12 is what, 300, I think. Correct me if I'm wrong, but I'm pretty sure it's 300. 300 months are in 25 years. So it's 300 months. The future value for this is going to be 0. At the end of 25 years, you don't get your $175,000 back. They're not going to keep paying you. It's just you got what you got. So your future value is going to be 0. Your present value is going to be what you're paying them today. And again, because you're giving this to them, it's going out. It's a negative $175,000. Present value, negative. And the payment is going to be what you receive every month from this investment. So in this case, because it's coming to you, $1,500 a month, you would put in positive 1,500 here. You don't have to put a plus sign in there, just put 1,500 in there. And so now we should be able to figure out what and this will give us, because we're doing everything in months here, this will give us the average monthly rate. So if we want to figure out, and that's not terribly helpful because most of the time we want to know what the annual rate is, we'll just have to multiply that number by 12 to get there. So, but let's do that right here. So again, equal rate bracket. So now it's asking me for n per first. And these functions will ask you for these things in different orders, so you actually can't just copy one and then redo, like change FV to PV or FV to rate. You will want to enter these from the start as a rate function, so you know it's pulling the right information. So we did number of time periods, payment, comma. Again, this is just, as you go along, this is bolding up what you need to put in next. Present value, comma, future value. And then again, we're not doing type. And in this case, they say guess. You don't need to do guess either. You get those 4 variables in there and then you hit enter. And this gives you 1%. I'm going to add some decimal places to it. So because right now it's just 0. So this is 0.77% per month is the average rate of return. But I really want to figure out what this is on an annual basis. So you just take that and you multiply it by 12. And you can do this the same way. Instead of entering 0.077 or 0.0077 times 12, you can say equal, and then you can click on this cell right here where your 0.77 is, and then hit times 12. And that will figure out the rate on a yearly basis. So I hit enter. Why didn't that do? Oh, that's because it's text. Got to be careful with formats of these cells, because if they're text, they won't calculate anything for you. There we go. I'm going to make this interest rate. So, and just like with financial ratios, I'd like you to calculate everything to 2 decimal places, so to the hundredths. So on average, this is actually a pretty good annuity. You are earning 9.26% on this $175,000 that you're giving this company in the form of these 300 payments at $1,500 a month over 25 years. That's the average interest rate that you were earning. If they were only paying you $1,000 a month, then your interest rate, then you're only earning 4.77% on that. So,
I didn't get that same rate.
what's that?
I didn't get the same rate. Maybe I'm doing wrong.
You didn't get the 0.77?
No, I'm equal RAT rate. Then there's the sign, and it's asking me for different, which is 300. And then it's asking me, which is 1,500. I get 1%.
Yes, that's because it's not showing you to 2 decimal places. If you if you increase the so these numbers, these zeros up here in the taskbar, one of them will increase the decimal places, the one on the left, and the one on the right will decrease it. So you need to increase it twice.
0.0 or 0.77.
Yeah.
And then you times that by 2.
Yep. Yep. All right. So that.
When I typed in my equation, it just has it says equals rate and then all the cells typed out. It didn't formulate anything.
Yeah, so some of these cells, if you click on that cell, whichever one it is, click on it once, and then if you go up to the top here, there's something that will tell you what format. Does that say text?
Yeah.
So you need to change that. Click on the little down arrow and change it to number. And then,
Oh, okay.
yeah, and then it should calculate. Whenever these cells can be set up to be a number, a percentage, or there's a few different options. And if it's set to text, that just means that Excel isn't going to try to calculate anything. It's just going to let you put whatever you want in there, and it's just going to show you that. So.
Okay.
Yeah, so if you get something like I just did and it didn't show you the calculation, if it just showed you what you typed in, then you should check up above and make sure it's not on text.
Okay.
Okay. Any other questions about that? The rate function? Okay. All right. So that's an annuity. So, and that will tell you. Yes, you end up getting 450,000, Melissa. But because it's not right away, because it's over 25 years, it's the equivalent of 9.26%. So it's not the same. Getting that amount of money over 25 years is not the same as having $450,000 today, right? So that's sort of what it gets back to compounding, and so that's the difference there. So you'll get a total of that, but it will be over 25 years. Yeah. I don't know why my screen keeps freaking out here. Okay. Wow. My monitor is going crazy. So let's do number 4 here. So this one, so some of these functions work well in helping to determine interest rates on bonds, or what a particular bond would be worth based on these variables. And again, a bond is just, from your perspective as an investor, it's you giving a government or a company an amount of money, $1,000, and in return they guarantee you to pay back $1,000 in a certain number of years. In addition to that, they guarantee to pay you a certain extra amount of interest on top of that. That's what a bond is, right? And so what we're going to do right now, so number 4 says U.S. government is selling a 10-year bond, which means that it's lasts for 10 years, and at the end of the 10 years, they'll give you your $1,000 back. That will pay $1,000 at maturity, so you'll get $1,000 in 10 years. If you are seeking at least a return of 5% annually, what is the maximum you would be willing to pay for this bond? And so how bonds work is they might pay $1,000 in 10 years, but so you're going to pay some amount less than $1,000 right now, $850 or $910, whatever it is. And so what you need to figure out is your earnings are going to be the difference between what you pay today and what you get 10 years from now. So how do you figure out what interest rate that is? So that's what these calculations will help us determine. Actually, this is going to help us determine what we should pay for a bond today if we want at least 5% annually. So this number 4 is actually a present value question. So it's a PV question. So I'm going to go up to my PV area here. And so let's see, 5% annually. So we can do this by year now because everything is in years. It's not months. So we don't have to do those calculations. So we're going to go ahead and put in 0.05 for 5%. Number of time periods, it's going to be 10 for 10 years. Future value. So this is where the $1,000 come in. In 10 years, you're going to get $1,000. The government's going to pay you $1,000. So that's where 1,000. So it's a positive $1,000. The present value is what we're trying to figure out. And in this part of the question, there is no payment. I'll talk about payments here in a second. So we just put 0 in there. So I go back here and I say equals PV, bracket, rate, comma, N per, comma, payment, comma, FV. Again, we don't have to enter type. So once I've clicked on those 4 cells, I hit enter. And it shows me this negative $613.91. What that means is that if you want to earn 5% on this bond, that'll give you $1,000 in 10 years. You shouldn't pay any more than $613.91 today, because that's what would equal a 5% return. If you gave them that money today and they held it for 10 years, and in 10 years they gave you $1,000, that would be the equivalent of earning 5% on $613.91. That's how bonds work. They don't work like say savings or certificates of deposit, where you put in an amount of money and they give you interest every month. You pay a certain amount at the beginning and you get a certain amount back at the end. And the difference between those two is what you earn. And so then you have to calculate what the interest rate on that is. So that should be the maximum that you would be willing to pay for one of these bonds if you wanted to earn at least 5%. If you were willing to earn, say, 4%, do you think this number here would go up or down if you were willing to accept only a 4% return?
Go up.
It would go up. You would be willing to pay more today. So if I put in 0.04 there, it should go up from 613 to 675. So that means the difference between that and 1,000 is less. So that essentially means our interest rate, our rate of return, is lower too. Okay. Let's see. I'm going to put 0.5 back in there. The second part of that question is, what would you be willing to pay if that same bond that we just calculated also paid an annual coupon of $20 for 10 years? What's an annual coupon? Anybody know what that is?
Is that the interest they pay for you once a year based off your coupon, right?
Yeah, so a coupon is, in addition to getting the money back at the end of this process, some bonds pay a coupon, which means that in this case, every year you're going to get a check for $20, in addition to getting $1,000 back at the end of 10 years. So when we change it up here, we say, okay, all of this stuff stayed the same, but now we're also receiving $20 every year for 10 years. So what would that interest rate, or what would we be willing to pay for that? So if I put in 20 here, is our present value going to go up or down? What I would be willing to pay for that.
So it's, I would say go down, or go up, right?
Let's see.
Or it went up like
Yes.
$100
Yeah.
Like
It,
768.
yes. It would go up because you were not only earning this $1,000 at the end, but you're also basically earning $20 a year for 10 years, so an extra 200. So you should be willing to pay more for that.
It makes sense.
Yeah. Yeah. So,
But you wouldn't want to pay $1,000 for that one, right?
you would not want to pay $1,000 unless you just wanted the government to keep your money safe for you.
I just don't know that. So how do you get government bonds? You just call a number, United States government, and they'll tell you it's like full question. You want 5%? How much you willing to pay on it?
Well, there are savings bonds out there that don't operate like this. Most treasury bills, which are government bonds that they sell, are sold in denominations of like $1 million.
Okay.
So to get access to those, you would typically go into a mutual fund or something like that.
Okay.
But yeah, they're pretty large issues, and so then a stockbroker or a securities dealer would buy them and basically resell shares or small portions of it to other people. So
Okay.
yeah. All right, so that is present. That's figuring out the present value of something. Any questions on that function? We're running out of time. Okay, so I'm just going to let you know this right now so you're not stressing about next week. This material will not be on the test on next Tuesday, because I don't like to give material out one day and not let you practice it and come back and review it. So we're just going to be doing chapters 1 through 4 on the test for next week, since we've had a chance to practice that and review it. I'll put that on Canvas too. All right, so I think we have one more example there. Let me just do this. And Number 5. Number 5 is another bond question, but it's asking a slightly different question. General Electric is selling bonds that pay $5,000 at maturity in 5 years. That means instead of getting $5,000 in 10 years, you get it in 5. That's what maturity means. It means you harvest your investment. The bonds are currently selling for $4,098. What is the equivalent interest rate for this investment? So this is going to be a rate investment again. I thought I had one.
Use the input function?
No, we would use the rate function, but I want to do one n per function. I thought I had one in there, but I didn't. So let me invent one. Oh, okay. So here's a good question. We're going to skip number 5 so we can do one of these n pers, which is number of time periods. So I'm just going to read this to you. So here's the question. How long will it take to accumulate $100,000 for retirement if I currently invest $25,000 and it earns an average rate of return of 7%? So this is number of time periods. How long? How long will it take to accumulate that? So you want to know, basically it's saying you want 100,000 for retirement. Hopefully you're going to have more than that, but 100,000. And you have 25,000 to invest right now, and it's going to earn an average of 7%. How long is it going to take you to get there? So that is an n per function here. So let's just put this, and we're going to do this in years, so it should be pretty easy to enter these. We don't have to calculate anything. 0.07 for 7%. I don't know why that's not in a percent. There we go. We're trying to figure out the number of years. The future value, we want that to be positive $100,000. That's what we want to be able to take away from this. Present value is what we have to contribute, which is the 25,000. Negative 25,000. And there is no payment here. We're going to assume we just plunk in $25,000 right now, and it earns 7%. How long will it take to get to $100,000? So n per rate, comma, payment, comma, PV, comma, FV, hit enter, 20.489, whatever. Take that down to 2 decimal places. So that will basically take you 20 and a half years if you want to get to $100,000 by investing $25,000 and having it earn an average of 7% over that 20 and a half years. So this is a good one to sort of help you estimate how long it would take to get to a certain amount if you had this amount of money to give and it was going to earn this rate of return. The second part of this question, we can change it up a little bit again, and we can say, but what happens, say, if I invest $2,000 every year during that time, in addition to putting in this $25,000 at the beginning? If I put in $2,000 every year as a payment, so this would be negative $2,000 every year. I'm going to be putting in another $2,000. Is it going to be more? Is it going to take me more or less time to get to 100,000? Less. Should, I hope. Let's see how much less. A lot less. So if we put in $2,000 a year, it only takes us less than 13 years to get to $100,000 at 7%. Again, and this is a reflection of compounding because it's utilizing that concept, that calculation of compounding to figure out things in, again, for either time periods, what you're going to have in the future, what you have in the present, or even your payments. Those payment values are being compounded also. Okay. All right, any questions on the payment function? Okay, I'm going to show you this last function. I don't think you're going to have time to practice any of this, but there is an assignment, so you will get a chance to practice it this week. So this last one down here at the bottom is IRR. Again, this stands for internal rate of return. And again, this is used when you have an uneven rate of return over a number of years. And this is pretty typical in the business world. It's not like you invest $1 million in a piece of equipment and it will give you exactly 5% return for its useful life or whatever, 10 years. It tends to change throughout time. If it's a piece of equipment, you may get a lot of return out of it initially, but then it slowly starts to degrade and it's worth less and less. So if it's something like you're renovating hotel rooms or a restaurant or a casino, you're going to get a higher return initially, and then it's also going to go down like that. Sometimes, though, in investment, it could take a while. You could have a lower return, say your first year. If you changed up a menu on a restaurant and had to advertise that out, a lot of times it takes a while for people to get to know that. So maybe in your first year you don't earn as much, but then in the second and third year you start earning more. And then as it gets older and older and staler and people aren't excited about those menu items anymore, then it starts to go down again. And so what IRR allows you to do is to calculate what the average rate of return is on these uneven yearly returns. So in this example here, we have two different projects, Project X and Project Y. So descriptive. Both of them, you have an initial investment of $100,000. So again, if you're investing money, if you're a business or an individual and that money is going out from you, that's a negative. That's a negative number. And then in years Y1, Y2, Y3, this just stands for year 1, year 2, year 3, year 4, year 5. In the years following that investment, this is the amount that they earn for Project X, $10,000 in the first year, $20,000 in the second year, and $30,000 in years 3, 4, and 5. But in Project, and again, this is the exact same initial investment, $100,000. In Project Y, though, it's different. They earn less. They earn $5,000 the first year, $20,000 in the second year, $30,000 in years 3 and 4, but then in year 5 they earn $35,000. So these returns are much different, and so we need to figure out a way to compare these two investments. It's really what we're doing. We're trying to figure out which is the better investment, which gives a higher rate of return. So how we do this is use this IRR function. So the easiest, and the other thing just to see here, I'll show, or the other thing that I want to show you here is that, so over the, oh wow, that shouldn't be percent. Let's make that number. There we go. Over the 5 years, Project X will return $120,000 to the owner of this project from the initial $100,000 investment. Project Y will also return $120,000. So over that course of time, they're returning the same amount of, exact same amount of money, but they're doing it at different rates, which means that the interest rates are going to be different, the average interest rate. So that's what we figure out here. So I'm going to put in equal IRR, just like the other ones. And now for this one, it just says values. So this is sort of key for IRR. You always want to start out with what your initial investment is and make sure it's a negative number. And then after that, you have your series of returns, and they should be sequential. So year 1 goes first, year 2 second, which is why I have them lined up this way. All you have to do to select these values, though, assuming they're set up this way, is to click here, hold down your left mouse button, and drag it down to the bottom there, not all the way to 120, because that was just something I put in there to show you that the sum was the same. And release. So now you have these cells selected. If I hit enter, it gives me this number here, 6%. Again, we're going to 2 decimal places, so I'm going to add a few. 5.55. See, it rounded it up there. So that's for Project X. Again, what I could do is I could just copy this cell right here, and it should give me the same calculation, but I'm not. I'm going to do this. Do it the old-fashioned way. I'm going to type it in, equals IRR, and then select the cells, and then hit enter. 5%. I'm going to add a few decimal places. That 5.27%. So which of these projects would you choose if this was the only criteria upon which you were choosing these projects? X has a higher rate of return, 5.55% versus 5.27. Just like the other functions too, if your numbers change, if you think your forecasts are going to be different, then you can change some of these numbers and say, oh yeah, we're actually going to earn $35,000 in year 4 on this one. So then I put 35,000. I don't have to retype in the formula below, but it recalculates what that return is. So it goes up to 6.47%. So again, this is another reason why, although you could enter numbers directly into this formula thing here, you really want to use cells. It makes your life a lot easier, and it's probably the way that you would use it in the, well, we're in the real world, but in the real world out there. All right, so that's internal rate of return. Any questions on that or any of these other functions, since we appear to have arrived at the end of our rope for tonight? There's, yes, yeah. These, just like the financial financial ratio calculations, this just takes practice. So it may seem really strange to you right now, but if you use it and really play around with it is what I would encourage you to do. You can create your own little problems and pick your own variables and just see what the different calculations do. It's pretty easy to calculate things. So. And these are skills that you really, I think you will be using in the future if you're working in any sort of business context. So these are good functions to know.
Hey, Steve, when's your office hours? Or like if we have trouble this week, can we come see you?
Yeah, you can either come see me or you can we can set up a time to Zoom. I don't have set office hours, so it will be more of you and I just finding a time that works for both of us. So,
okay.
Yeah, just contact me via email or however, and we'll find a time to meet either in person or via Zoom, and yeah, we can do that.
Oh, okay.
Yep.
Thanks.
Mm-hmm. So for next week, if you go back and look on Canvas, there's a few assignments. If I go back here, under week 5. Time value of money assignment. So that's what we've just been working on. And again, this is under assignments is where you submit it, but the actual numbers are up here. So you have time value of money assignment. That's where you get the numbers. You can use that spreadsheet, that blank time value of money spreadsheet, to do the calculations if you want. I would recommend that. And then there's a Hagen financial calculations assignment. So this is more of the Chapter 4 stuff that we were working on last week. So the return on equity, return on assets. So there is, the financial statements are right there. The worksheet is right under there. So again, it's just those 10 financial calculations. So that's for next week. And then again, assuming that I get you all set up on the nation-owned enterprises module in the next couple days, and I'll let you know as soon as that happens. I'll want you to get to quiz number 1 in that module by next Tuesday, and then of course prepare for test number 1 next Tuesday night. That's all I got. Any other questions, comments, sounds that you want to share?
So if there was no immunities, bonds, or stock, governments or companies have to raise capital by selling stuff only, right?
If there were no annuities, stocks, or bonds, yes. So stocks and bonds are the 2 primary ways public companies raise money. A bond is essentially a loan. You're giving them a loan, and a stock is they're selling part of their company to you, a very small part. So yeah.
I mean, bonds and these are important for the whole back end, right? If nobody participated in doing these bonds or stocks, the whole world, the economy would fall, right?
The economy would be much different. Yeah,
okay.
You wouldn't have these massive corporations, I can tell you that. Okay. I mean, that's what allows some of these companies to get so big, is because they can raise billions of dollars in one stock offering, and then they can go buy a bunch of stuff with it, you know, or build a bunch of stuff with it. And yeah, so stocks and bonds are really key in the whole, in the U.S., actually not just the U.S., but in any capitalist market for companies to raise money. Yeah. All right. Well, again, you can contact me this week if you need to meet up and via virtual land or in person, or if you have any questions, you can email me too. I will be available, and I'll try to get all the homework graded by Friday. So that's my task. Have a good night.
Good night.
Night, Austin.